Hey guys, today we're looking at 4.3, the graphs of the tangent and cotangent functions. So last time we looked at the sine and cosine functions. Now we're going to look at tangent and cotangent functions. They look a little different, you may have noticed. Instead of making the wave shape, now we've got a little squiggle shape, I guess is a good way to describe it. And you'll notice that this time our domain is a little bit different. So if we're talking about our domain, we have some asymptotes that are going to change our domain. So when we're talking about our asymptotes, that's what for tangent is this right here. X cannot equal pi over 2 plus n pi. So for our tangent and cotangent functions, our period has shifted to just be pi instead of 2 pi. And so when we're looking at finding those asymptotes, they're on either end of our period for this one. So we're going from negative pi over 2 to pi over 2. And they follow that pi over 2 plus n pi. So we're going to go from negative pi over 2 to pi over 2. And then we can keep following that pattern by changing n to be any other integer. So if we have the pi over 2, n is technically 0. So then we would add 1. So then that would jump up to pi over 2 plus pi, which would be 3 pi over 2. We could say n is 2 and keep following that pattern to find all of our other asymptotes. And you'll notice our range is also a little bit different this time too. Our range is from negative infinity to positive infinity. You'll notice our graphs have arrows on the end of them here. So we go all the way down on the left side, all the way up on the right side. It's still a periodic function, so it is going to take this shape and it's going to repeat it over and over and over and over and over again. So it's just going to look a little different than the wave does. So it is discontinuous at values of x of the form x equals pi over 2 plus n pi. That's the vertical asymptotes we were just talking about up here that I have boxed in pink, so I'll highlight it in pink. Its x-intercepts are of the form x equals n pi. So her first one here is just at 0. That would be 0 pi. Then I would have it at 1 pi, 2 pi, 3 pi, 4 pi, so on. And I can go in the negative direction too. Negative pi, negative 2 pi, negative 3 pi, negative 4 pi. When we're talking about these, the next little thing is the period, which we already talked about. And the next little bullet point says that the graph has no amplitude since there are no minimum or maximum values. We're not talking about a wave anymore, so we don't have an amplitude to look at anymore. But we still need to determine if it's even or odd. So if we're looking at it, the graph is symmetric with respect to the origin, which means it's got that rotational symmetry that our odd functions have. So the tangent of negative x is equal to negative tangent of x. Now let's look at cotangent. You'll notice cotangent kind of similar, just and looks a little different. Instead of being centered at that origin, now we're going from 0 to pi. And instead of being an increasing function, now it's a decreasing function. We're going down as we go to the right. So you'll notice our asymptotes are also a little different. Instead of being the x cannot equal pi over 2 plus n pi, now it's just x cannot equal the n pi. So we start at 0, and then n pi would be pi, 2 pi, 3 pi, 4 pi, also in the negative direction. So our asymptotes are a little bit different here. The range is still the same, negative infinity to positive infinity. Okay, we still have that same period of pi, and that is up here in our asymptote equation as well. So the graph is discontinuous where we have those asymptotes. Discontinuous at the vertical asymptotes where x equals n pi. And you'll notice this time when we talk about our x-intercepts are of the form x equals pi over 2 plus n pi. So you can see that where the asymptotes and the x-intercepts are have kind of switched places here. So if we're looking at this, the next thing Once again, the graph has no amplitude since there are no minimums or maximum values. And also, if we're looking at this, we got to talk about that symmetry. If we are talking about it being even or odd, when we look at the graph, this one is still an odd function. So it still has symmetry with respect to the origin. It's an odd function, and cotangent of negative x is still equal to negative cotangent of x. So it's not like yesterday where sine and cosine were opposites. These are both odd functions. Okay, that's kind of what these two look like. Zoom out a little bit so you can see them both. We've got the tables over on the side as well to kind of help you get some of those points. We've got the two asymptotes that are the undefined, and then you'll notice for the tangent we have negative 1, 0, 1, and for the cotangent we have 1, 0, 1. That actually should be 1, 0, negative 1. That's a typo right there for our y values. And then you'll notice that the x values are a little bit different than the x values we had last time. So for the tangent, we have negative pi over 2, negative pi over 4, 0, pi over 4, and then pi over 2. And for our cotangent, we go 0, then pi over 4, pi over 2, 3 pi over 4, and then pi. Let's look at some graphs, let's look at some examples, and let's see what's happening here. So for example 1, if I'm looking, I have y equals negative 3 tangent of 1 half x. So if I were to look at this, I need to figure out kind of the same steps we did last time, figure out what my x values are going to be, and that's going to start by figuring out my period. So I'm going to make a table over here. And just like last time, I'm going to kind of split it into some equal parts. If I'm looking at this one, I know from my table up here that I need 1, 2, 3, 4, 5 spots. But what's a little bit different than last time is that it's not going to start at 0 necessarily. So I'm just going to draw the 5 spots and we'll talk about how to figure out where you're going from there. So I'm going to cheat a little bit and copy and paste to help me. So 1, 2, 3, 4, and finishing it off there, 5. So if I'm looking at this, when I'm looking at my tangent graph, you'll notice that the tangent graph is kind of centered at that 0, 0, and then on either side, it goes off to your asymptotes. So instead of my 0 being on the far left, I'm going to put my 0 in the middle here. And then my period is where I'm going to kind of figure out what's going to go on either end. So remember last time when we talked about our period, we did our current period divided by b. So last time for sine and cosine, it was 2 pi. But if we look at this, our period for our tangent graph and for our cotangent graph is pi. So now our formula has changed a little bit. Instead of being 2 pi over b, now it's going to be pi over b. B is still just the part that's in front of the x. So I'm going to have pi over 1 half. Now remember, I don't want to divide by a fraction. So I can do my keep change flip. I'm going to have pi now times 2 over 1, or just pi times 2, which is 2 pi. So my period is 2 pi. And now to figure out where I'm going on either end, it's going to be a little bit different than it was for my sine and my cosine. So I'm going to kind of sketch over here. I know that in the very middle is 0. So to figure out the end points, if 0 is the very middle, what I'm going to do is I'm going to go halfway on either end to figure out the end. Because if 0 is in the middle, I got to go half to the left and half to the right. So I'm going to do half of 2 pi and half of 2 pi there. So half of 2 pi is just pi. But we are going one in the negative and one in the positive. So this one's going to be a negative pi and this one's going to be a positive pi. So another way that you could fix that if you would like to is make this negative 1/2 right there. So then from there, I need to go a fourth to fill in these spots. So negative 1/4 of 2 pi and 1/4 of 2 pi. So that gets me negative 2 pi over 4, or negative pi over 2. And right here, that gets me 2 pi over 4, or pi over 2. We can kind of see how we fill in from the middle out for tangent, as opposed to the other time with sine and cosine, where we would start on the far left and move over to the right. Now, what we do know here is those two far ends are asymptotes. Both here and here are asymptotes. That means that these are going to be undefined. There we go. And then in the middle is where I've got to figure out what my values are. Another thing is that you might have to write the equation for the asymptotes. And so to write that, the easy way to kind of find the equation is that the first part is half of the period. I can't spell. Half of the period. And then plus whatever your period is times n. And they are vertical, so they are going to be x equals. Well, if my period is 2 pi, I can say plus 2 pi n, because my period's 2 pi. And then half of that would just be pi. So over here, it would be pi. So that would be the equation for my asymptotes using my period. This would be something that would be really helpful to remember. Half of the period plus the period times n. Now to fill in those middle points, we are still going to use our coefficient up here with our transformations like we did with our sine and our cosine for our amplitude, but we're just not going to call it amplitude because it's not a wave, so we don't technically have an amplitude. So if I have that -3, that does mean that I'm going to reflect and stretch by 3. So if I am reflecting and stretching by 3, normally for the tangent, we would have right here a -1, 0, and then a 1. So those are going to be what's changing. Instead of -1, 0, and 1, if we're reflecting, it's going to be positive. And then if that's a 3, now it's going to be a positive 3. The 0 is going to stay the same. And then the 1, reflecting, is going to become negative. And we're going to stretch it by a factor of 3. So now I've got everything there. Let's go ahead and put it on our graph. So remember, we're going out to the left and to the right. So this one's at negative pi over 2, positive pi over 2, positive pi. We've got those asymptotes going up and down, the negative pi and the positive pi. And then we go up 3 and down 3. So over here, we're going to be up at 3, 0, and -3, and then I just kind of connect it so that it kind of makes that curved shape. So kind of looks like this. There we go. It kind of sort of looks like the cubic graph, but not exactly. It's got those asymptotes in there and it's not quite as curved. Okay, let's look at another one. And you'll notice there is something a little bit different about this equation. I'm throwing in another transformation. What happens when we add or subtract things outside of our function? So you should remember from algebra that that means that we are going to be shifting up or down. And in this case, since I'm adding 2, that means I'm going to be shifting up 2. So this one, we are just still looking at a tangent. I'm going to copy my table over, make it a little bit easier for me. So if I am talking about my tangent graph, remember we kind of start with that 0 in the middle. We need to find our period. So that would be pi over b now, because remember we start with our old period, our normal period, which for tangent and cotangent is pi. Now, if you look, there is no b value. So that means it's technically just 1. So if I did pi over 1, my period's still just pi. Which means that I can just use the same values that I have here in my table, the negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. My period didn't change, so I'm going to use those same values. Negative pi over 2, excuse me, negative pi over 4, pi over 4, and pi over 2. Ooh, started choking. Okay, now to find our y values, we need to look at if we have anything in front of our tangent, like a negative or a number that normally for sine or cosine would change our amplitude, but here would just be a stretch or a shrink. So you can see right here that there's nothing in front of our tangent. So we don't have a reflection or a stretch or a shrink or anything. However, that plus 2 is going to change our tangent. So remember here, we do have our asymptotes, our undefined. And then here would normally be -1, 0, and 1. But since we're going up 2, -1, I'm going to add 2 to it to get up to 1. 0 plus 2 is 2, and 1 plus 2 is 3. So I'm just taking my entire graph and just shifting everything up 2. Okay, let's graph it. So coming back and forward, we've got negative pi over 2, negative pi over 4, pi over 4, and pi over 2. I'm going to put my asymptotes going up and down, back here, and up here. And then everything is shifted up, so I need to be up at 1, 2, and 3. So 1, 2, and 3. And it's just going to kind of go like this. Okay, let's look at another one. This time we've got a cotangent. Okay, we're going to start the same way. We are going to find our period. Okay, for cotangent though, we are going to start at that 0. So if you look at cotangent, it does start at 0 and go to pi. So this one is kind of our normal sine and cosine way. The tangent one is the one that's a little weird. So I can go ahead and put my 0 on the end over here. Okay, if I'm trying to find my period, remember it's pi over b. And if you look, there's not anything I'm multiplying there. So pi over 1 means it's still just pi, which means I can use my points from here. My 0, pi over 2, sorry, pi over 4, then pi over 2, 3 pi over 4, and pi. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. Makes it nice and easy. I don't have to worry about breaking it down like we did last set of notes for sine and cosine. Okay, on either end are my asymptotes, and you may have to write your equation for your asymptotes. So for my cotangent, my asymptotes are just my period times n. Also something that would be really helpful to remember. Okay, they're vertical lines, so it's going to be x equals, my period is pi, so pi times n. There's my equation for my asymptotes for this one. And I totally skipped over that for the last one. The last one was a tangent, so it follows the equation above it, half the period plus period times n. So my period was pi. So that would be plus pi times n, x equals for the vertical line, and half the period would be pi over 2. So that would be the equation for the asymptotes in example 2. My bad. I think I got caught up in the choking and skipped over it. Okay, now I need to fill in these missing y values. Oh. Okay, if you notice right here, I've got a negative in front of my cotangent, which means I'm going to be reflected. I also have a negative 2 here, which means I'm going to move down 2. So all of that is going to factor in to this. So for my cotangent, I normally have 1, 0, then negative 1. So if it's normally 1, 0, then negative 1, first of all, if I reflect it, that would be negative 1, 0, 1. And then I'm going to move them all down 2. So negative 1 minus 2 would be negative 3. 0 minus 2 is negative 2. And 1 minus 2 is negative 1. So that would be the points that I would use. So let's graph it. Got the pi over 4, pi over 2, 3 pi over 4, and pi. Okay, I'm gonna have my asymptote going up and down over here at the pi, purple, and up in here at 0. Do the best you can to kind of make it visible there. And then I'm at negative 1, negative 2, and negative 3. So negative 3, negative 2, negative 1. It's going to go up this way, like that. And then my last two, they determine an equation for each graph below. So you need to figure out if it is a tangent or a cotangent. Okay, where your asymptotes are, where you're centered, is going to be the dead giveaway of which one you're going to use. So if I'm looking at this right here, because I have a point at 0, 0, that's a dead giveaway that it's a tangent. In this one, because my asymptote is going up and down, that's a dead giveaway that it's a cotangent. Remember, for our class, we are not looking at our horizontal translations or shifts left and right. So looking at this tangent one, First thing I will notice is that we are at 0, 0, which means we haven't been shifted up or down. So from here, I need to start looking at, do I have a reflection, a stretch, or a shrink to figure out if there's something that's going to go in front of my tangent. So remember, our tangent does normally start in the bottom and go up. A tangent is normally increasing. And this one is starting in the top, so that does mean that it's been reflected. And the point's hitting at 2, so if it's been reflected and hitting at 2, that means I'm going to have a negative 2 in front. Then to figure out my B value, I need to look at my asymptotes to help me figure out what my period is. So if you look, going from negative pi over 2 to pi over 2, that's where my asymptotes normally are. Negative pi over 2 and pi over 2. So my period has not changed. So that means that I don't have anything in front of my B. My period is still just pi, so there's no B value, and that's my equation. Coming over here to look at my cotangent one, if I look, my cotangent does normally start in the top and go down, so it's not reflected. That's good. But you will notice that it's been shifted down. So this is still up 1 and down 1, so there's no stretch or shrink. But instead of being centered at the axis, everything's been shifted down 1 unit. So what I'm going to do is I'm going to say that up here, I have a negative 1 plus my cotangent. Then normally we go from 0 to pi for my period, but you'll notice we're only going to pi over 2. So I would do pi over b is equal to that pi over 2. I can cross multiply here. So that's going to get me 2 pi is equal to pi times b. And I can divide both sides by pi to get that b is equal to 2. And that's what's going to go in right here. And there is my equation. Thank you for bearing with me through that choking fit. I have no idea what just happened. Sorry about that. That's it for this set of notes. Let me know if you guys have any questions. Get started on your assignment that goes with this. And y'all have a good day.